Hello, this is Corey Applegate, mentor of the Grand City GearHeads, Team 3244 out of St. Cloud, Minnesota. Welcome to week 2 of building our 2020 robot chassis in Fusion 360. Last week we created an overall sketch for our chassis rails and bumper mounts. We extruded the rails, hollowed the mount using the shell command, and also created a rigid group and grounded the chassis to stay in place. This week we're going to add some of the feature holes that we're going to need later on, as well as the holes that are pre-drilled in the Versa chassis tubing system. To start out, we're going to make a few changes to our chassis from last week, and we're going to explore another part of making this chassis more dynamic. We're going to go look at the parameters, the modify parameters. We're going to create a couple user parameters that we can use to drive the hole patterns, as well as the size of our chassis. Under user parameters, we're going to add a parameter. The first parameter we're going to create is drive train using camel casing, because there can be no spaces here. These user parameters are going to be unitless, so we're going to pick no units. We'll add the units as we need them. And the expression is the width 27.5. Create another user parameter, drive train length. Camel casing as we go. Also no units at 32. Okay. When we created our original, we created at the top level, and here's a sketch 1. We need to go back and rename that. Again, remember, rule 1 is to start with a new component. Rule 2 is rename all your sketches. I have a tough time with that, but we'll go back and rename that. We're going to change these static numbers to reflect our user parameters. So, drivetrain width times 1 inch to give it some units. Drivetrain length times 1 inch. It's a little quirky thing with Fusion 360. You can't just put the units on there. You must multiply it to add the units. It's very literal. Like when you divide units by units, units cancel out. Here when we multiply units, units add in. Now you can see if I went ahead and change this to 40, our chassis will change and update accordingly. The first thing we're going to do is we're going to add the holes to the top of all these tubes, and actually through the entire tube. To start that, we're going to start a new sketch, and since this sketch is going to drive many different components, we're going to stay at the top of the project tree. Create a new sketch. One of the things we're going to need is we're going to need some geometry, reference geometry to all these items. So we're going to go ahead and create some projections onto the sketch plane by going into create, project include, and project. We're using the shortcut key, letter P. And we're going to select the top of each one of these rails to project the perimeters to the sketch plane. Now we're going to create 6 points that we can use to create holes in the start of each tube. We're going to work our way reverse from right to left, adding a point generally in the beginning of each tube. We're going to start adding some constraints to these points. These top few points are going to be always centered, using the shift key to pull up the midpoint constraint. This one's going to be midpoint to that. This point is going to be driven by any dimensioning we give to him. This point will always be vertically in line with this lower point. These 2 points are always going to be horizontally in line, as well as these 2 points we always want to stay horizontally aligned. This point, we want to make sure it's always in the center of the tube, as well as this point, center in the tube. This point's going to be horizontally centered to the tube. You can see a couple of our points are already starting to lock into place. And this one, vertical. As they turn black, they are fully constrained. There's a few more white dots that we must dimension. We always want to make sure this dot and this dot are some pitch of 1 inch, since that is what the Versa chassis system typically uses. You can go 1/2 inch, but this one we're going to drive at 1 inch. And these two are going to be in the pitch of something divisible by 1 inch. Now that each one of our points is fully constrained, we'll finish the sketch. And we're going to go use our hole tool. We're going to start out by selecting the points that we created. Six holes. The hole diameter is going to be 0.163, the factory hole diameter of the Versa tubing. And for a distance, we're going to make sure that each hole always drives to the bottom plane. We're going to start patterning these holes. We'll do 3 patterns. One pattern for the 2 sets of holes running up the side rails, one pattern for the bumpers, and one pattern for the front and rear rails. This does get a little quirky at times. We may have to find some workarounds, but I'll show you those as they pop up. So the first pattern we're going to do a rectangular pattern. We're going to pattern a feature. Selecting each one of these holes. Second, we're going to select a direction to follow. We want to remain spacing. We can start dragging this arrow and we can start to see that there's going to be 3 holes at a spacing of 5 inches. Well, the Versa tubing is pitched at 1 inch. As for our quantity, we don't know what the quantity is going to be, because if we would dynamically change this, we would need these holes to change too. So we're going to reference that user parameter that we created, drive train length. You'll see it's going to create the holes for us. We're going to repeat those for the width, selecting the rectangular pattern, features, selecting hole number 1, hole number 2, a direction, spacing, 1 inch apart, drivetrain width. When this red comes up here, for some reason this wizard has been fighting me on the width. So right now I'm just going to add in a 12 in here. And to make this dynamic, we're going to go edit this using the modify parameters window. So you see we got only some of the holes. Create another pattern, taking hole number 1, hole number 2, selecting a direction, an edge to follow, spacing, a distance of 1, and I'm going to put that same 12 in here. Sometimes I can get and you should try adding that parameter in there first. If it doesn't work, enter in a raw number in there, and we'll go edit that in another field. So edit those numbers in another field, modify, change parameter. So these parameters we created before, we can go down and scroll on down to the drive rail left. You'll see there's an R pattern where we typed in the drivetrain left or length, and it took just fine. If we scroll down even further, we'll see our drive rail front. there's another pattern there with that 12 that we entered in there. For some reason or another, the formula is entering here just fine. I go ahead and take drivetrain width. It selects it. As well as the bumper front. If we go look at that, there's a pattern there. And in that pattern there's a 12. We can change that to the reference to drivetrain width. And hit OK. Now the whole pattern is complete. And if we bring up those parameter list again, we can change this to something extreme. The whole pattern follows the entire rail. We're back to 32 where we want it. Okay. Now that we have a set of holes, and you can see that we have a full length on one side, and every once in a while, as long as we stay within nice even half-inch pitch or quarter-inch pitch on all of our dimensions, we'll either get a little moon shape, but these brackets will still reach, keeping that we have this half-inch to 1-inch pitch. The next thing we're going to draw is holes for our gearbox assemblies and axles. And while I'm here, let's change the sketch name. Drive train perimeter. Versa tube holes. Even if we don't name our sketches right away, when we realize it, we can always go back and change it. It's just going to help us when we come back a day later, a week later, even a month later. So the next set of holes, as I said, we're going to drive is our gearbox and axle holes. I'm going to again stay at the top. I like to leave all my sketches that reference or drive multiple items at the top, and anything that's unique to that part, I'll sketch underneath that part. Starting a new sketch, I'm going to pick this outermost plane. With the West Coast chassis, typically we use what's called a drop center. The bottom wheel or the middle wheel will be always slightly lower than the outer two wheels. We'll start drawing our middle wheel here by first drawing a circle. This circle receives a standard half-inch hex bearing, which uses an OD of 1.125. We're going to apply some constraints to this circle, keeping a horizontal constraint to the origin, as well as a dimension from the origin, stepping the hole down 1/16 of an inch. There are a bunch of other holes that we're going to need to attach our Versa blocks in the system that the GearHeads use, but we're going to project those once those items are on there versus going to a reference drawing and sketching out all those individual parts. Next thing we're going to do here is I'm going to go back to construction. I'm just going to draw a circle here just to give us an idea of where the wheel might fall using the 6-inch wheel. We're going to draw a slot out here on the end. The outer wheels, again, are mounted to the top side, so to give us our drop center. What we do is we put a 1-inch slot out here, just inbound to the end of the rail for that adjustment. Staying in the construction line, I'm going to draw some geometry right here to start the slot. I'm going to rough in the slot, change this over to normal geometry. A width, undetermined yet, 1 inch tall, on center. The slot that we cut is a 1/4 inch long, center to center, and we place it 3.25 inches inbound. For reference, we'll draw a circle if the bearing block is dead center. 6 inches. And this way we can start to look at, what if we did change this to 3? The wheel gets tight and we start to run out of adjustment. So putting that back at 3.25. With these dimensions, you can see it's fully constrained, indicated by the fully black lines. We could go ahead and redraw all this over on the other side, but we're going to use a mirror. Since most of our chassis are always going to be equal distance from center wheel out in both directions, the mirror command works well. First thing we do is select our objects we want to window select what we want to mirror. Come on. And now we need a mirror plane. We could either turn on our origin planes, or just rifle through, waiting for the right one to highlight as it goes right there, and select it. Now we can see a preview of what we're going to get, and select OK. With these features all drawn on the sketch, we're going to finish the sketch, and we're going to use the extrude command. Up until this point, the extrude command has always created new objects. This time we're going to select the 3 profiles that we created, and either by grabbing hold of this arrow and dragging over, you can see Fusion automatically turn the operation from join or new body to cut. Since this is parametric modeling and we could change the width of this chassis at any time, we don't want to enter in just an arbitrary number here. We want to make sure that this cuts all the way through to the other side. So instead of using distance, we're going to use toObject. Panning around, we're going to select this outer wall of this tube to make sure that this cut always goes out to this outer wall. With that, we have all of our holes that we can use to place our bracketry on, as well as put our gearboxes and axles in. Until next week, we'll start placing those items on there, and we'll see you all at the Fusion Friday Zoom meetup or any open office hours coming soon.